from FET University of Colorado Boulder in order to show visual examples of current's relationship with voltage and resistance. This relationship was described in our infographic as Ohm's law, that being current equals the voltage divided by resistance. In this first circuit, I will be able to show the basics of Ohm's law. Though before I continue, there are a few things about circuits I should touch on first. Firstly, I will be using two pieces of equipment in this simulation to measure voltage and current. In order to measure voltage, which has units of volts, we use a voltmeter, which can determine the voltage drop between 2 points in a circuit. To measure current, which has units amperes, we use an ammeter. If we wanted to measure the resistance as well, we could, of which the units are ohms, we could use an ohm meter. Another thing I should touch on is that in order for Ohm's law to be satisfied, the voltage of the current must drop to zero before re-entering the battery through the negative end. The last thing to touch on is the two types of circuits I will be showing, that being series and parallel circuits. This first circuit is the most basic case of a series circuit. A circuit is considered in series when the current leaving the battery never branches and flows all in one branch, as seen. When looking at the first circuit, we have a 10-volt battery connected by wires to a 5 ohm resistor. Given this voltage and resistance, we can determine the current using Ohm's law, where current equals voltage divided by resistance. Using this, we would expect the current to be 2 amps, and we can check this using the ammeter. And as we see, the current is 2 amps throughout the entire circuit. We can also make sure the entire 10 volts is dropped across this resistor by placing a voltmeter across it. And we can see that all 10 volts get dropped across that resistor. Now looking at the second circuit, we can more easily describe a parallel circuit. A parallel circuit is one in which the current branches into multiple paths that the current can flow. This can be simplified even further when thinking about the water in a pipe analogy referenced in our text. If a water pipe is to branch into multiple smaller pipes, the current will split into these pipes, with more current entering a larger tube than it would a smaller one. The size of the pipe in this analogy symbolizes the resistance of a branch of a circuit, with a higher resistance being similar to a smaller pipe and a lower resistance being similar to a larger pipe. We see in this circuit there is the same 10-volt battery but now two 5 ohm resistors each in their own branch. Since voltage still needs to drop to zero in this circuit, the voltage drop across both resistors is 10 volts, which can be shown with the voltmeter. Using this voltage in the Ohm's law relationship, we can determine the current going through each branch. In this case, since both of the resistors are the same resistance, the current would split evenly, but if we were to make one resistor higher, say 10 ohms, we will see how the current is affected by this. Since the voltage drop across each branch is still 10 volts, we can use Ohm's law to still find the current. That being, we use the voltage dropped across, which would be 10 volts, and then the resistance of each branch. So for the 5 ohm case, we'd expect 2 amps of current, and for the 10 ohm case, we'd only expect 1. We can check this using an ammeter. We see 1 amp goes through the 10 ohm resistor and 2 amps goes through the 5 ohm. These then combine for 3 amps going through the entire circuit. Thus we see the lower the resistance, the more current. The higher the resistance, the less current. And this fits the water analogy because the smaller a pipe is, the less water that will flow through it, and the wider a pipe is, the more water that will flow through it. I hope this video helped visualize the flow of current in a circuit and made you realize any misconceptions you may have had. Thank you.